Find the solution of the given initial value problem. So we have a second order constant coefficient differential equation. So we'll get two solutions, and the general solution will be C1 first solution plus C2 times second solution, and we will find those C1 and C2 using these two initial conditions. Okay, so to solve, we first find the characteristic equation. That's 16r squared minus 8r plus 145 equals 0. Okay, now we solve this for r. The plus means we have to get 8 by addition of the factors of 145 times 16. Very small, so it's not going to happen. So let's use the quadratic formula to solve for r. So r is negative b, negative of negative 8 is 8, plus minus square root of b squared. Negative 8 is squared, that's 64, minus 4 times a, 16, times 145, that's 9280, over 2a, 2 times 16, 32. This is 8 plus minus square root of 64 minus 9280, that's 9216, negative, over 32. Take the square root of this, and this square root of negative number means something I, and that happens to be 96i, over 32. Separate into two fractions, 8 over 32, that's 1/4, plus minus 96 over 32, that's 3i. So the roots are in this form, lambda plus minus mu I. In this case, the solutions are given by this, and their linear combination will be the solution. So we write down the solution. Y as a function of t is C1 times first solution, E 1/4 t cosine mu t, so cosine 3t, plus C2, same thing but cosine is sine now, e raised to 1/4 t sine 3t. Let's write this solution in compact form. I want to factor this out, so e raised to 1/4 t out, C1 cosine 3t plus C2 sine 3t. Okay, this is the solution provided we know C1 and C2. Okay, for C1 and C2 now we use the initial conditions. The second initial condition requires us to use y prime. To find the derivative here, we have a product of two functions, so we need to use the product rule. So y prime t equals derivative of first factor, exponential function itself, times derivative of 1/4 t, which is 1/4. So 1/4 e raised to 1/4 t times everything, C1 cosine 3t plus C2 sine 3t, plus, okay, now we keep the first function alone and take the derivative of second, e raised to 1/4 t times derivative of second factor. Derivative of cosine is negative sine 3t times 3. So let me write over here, there is no room. So negative 3 C1 sine 3t plus derivative of sine is cosine, so 3 C2 cosine 3t. Okay, now the solution, the final answer is given from here, by the way, where we need to determine C1 and C2. We found y prime, just to use the second initial condition. Let's use the first initial condition, y at 0 equals -2. So using y at 0 equals -2, we get y is -2, okay, equals when t equals 0, so e raised to 0 1 c1 cosine 3 times 0, just 0 cosine 0 is 1, so c1 plus c2 sine 0. Sine 0 is 0, so there is nothing, so c1 is -2. Now use the second initial condition. Okay, so using y prime 0, the second initial condition is y prime 0 equals 1. So y prime at 0 equals 1. We get y prime is 1 when t is 0, so this is 1/4 e raised to 0 1, this is 1/4. c1 cosine 0 is 1, so the c1 plus c2 sine 0 is 0, plus e raised to 0, which is 1, -3c1 sine 0, that's 0, 3c2 cosine 0 is 1. And we know the value of c1, okay, which is -2, so let's plug in there and find the value of c2. So 1 equals 1/4 times c1, c1 is -2, so 1/4 times -2, so -1/2 plus 0 plus 3c2, just 3c2, move 1/2, so add 1/2 both sides, 1 plus 1/2, that's 3/2 equals 3c2, divided by 3, cancels 1/2, so c2 is 1/2. Now we have c1 and c2, just plug this back here and write the final answer. So thus y is given by 1 e raised to 1/4 t times c1, which is -2 cosine 3t, plus c2, c2 is 1/2 sine 3t. Final.